ExactFlat for SOLIDWORKS. In a previous video, we showed how we can take this office chair, which was modeled from scratch in SOLIDWORKS, create flat patterns using ExactFlat's 3D to 2D flattener. Here are the flat patterns shown. And what we're going to do now is we're going to show how we can take these flat patterns and create what we call marker sets. Marker sets are different sets of markers that we can compare. So we start with an auto-generated marker, which was automatically generated from ExactFlat based on characteristics from the database. And I'm just going to go and edit some of those characteristics right now. We're going to use a bound sheet. We'll change the length and height of the bound sheet. There we go. And we've already renamed this 2A. Now we're going to add another one, another marker, and I'm going to pick another material from the database. 124-inch cloth here. And I'm going to rename this marker. First of all, I'll change the lay rule to anyway, and I'll call it anyway. So now we've got two different nests with different fabric associated, and we are going to compare the yield on each of these to see if we get one better than the other. So we'll just click OK there and click OK here. So you can see at the top we've got a 2A and we've got 100 in anyway. And now we're just going to go and make some edits here. We're going to, instead of nesting 5 copies, let's change this to 20 copies and make that a global attribute. So all the markers in question will take on that characteristic. Back to our marker view. First, we're going to lay the marker out. So we delete the previous marker and we add the new one in. And it's a pretty simple process, you can see. And what this is just a box algorithm. Draws a polygon around the edges of the pieces and just lays them down. It's just a fast way to drag your pieces in. And now we're going to start. So we click our Nest All button. What the Nest All button is going to do is it's going to take all of the markers in our marker set and nest them in sequence. And you can see on the right-hand side we have our nesting status. This particular marker is set for a maximum runtime of a minute, but we could queue this up and we could have it run for longer. We could have it run overnight, depending on the stage of maturity of our nesting process. This could be a preliminary nest, or it could be one that might be going to production, in which case you'd probably want to run it longer. The bottom section where the markers are listed is where what is actively being nested right now. So you can see our progress is at 69%. And the algorithm, while it's set for a maximum runtime, this is the actual compaction algorithm, is set for a maximum runtime of 1 minute. It may actually take a little bit longer because there's some pre-compaction processes and some post-compaction processes that need to be run. So likely this will be in a range of like 2 minutes, just a little bit over 2 minutes. Those processes don't necessarily take longer if you have a longer runtime. So you can see we are at 100% already, and our execution time is about 1 minute and 30 seconds. So that gives you a sense of how long it'll take. Once the first marker is done, the second marker is then going to be queued up, and it's going to get ready to run as well. Now the second marker had different rules. As you can see, it had an anyway rotation lay rule. The first one generated a nest of 82% in about 1 minute. Not bad, but probably lots of room for optimization there. And we just click on the second one here, and you can see that the nesting process is starting, and it's taking on a very different view already out of the gate. So this should be another minute or so. But the real power of marker sets is it allows you to very quickly compare. If you're comparing for cost purposes or value engineering purposes or cost engineering purposes, you can get a very clear indication of what your yield might be based on different design attributes or material selection or lay rules or a variety of other criteria very early in the design process. Ultimately, this will help you to drive product quality and price value optimization. Very important for customers, very important for manufacturers. Just going to zoom in here. You can see the pieces, and we can edit edge buffers and and piece buffers as well very easily here, but we're just going to let this run. We're almost at 100%, and there you have it, this marker on bounded sheets. We could have any number of marker sets, so we need not stop at 2. We could have standard preset rules for marker sets as well. In this particular case, we have 2, and we're going to, once this is completed, it's a post-nesting process, we're going to accept both these nests, And then we are just going to save these as DXF files, possibly cut these for prototyping purposes. Okay, there we go. It's finished. Now we're just going to click accept, and we're going to click accept for the second one. I'm going to close out of here. There's the marker named Anyway shown. We're going to select the two-way marker, hit export, and we can export to a variety of preset criteria. In this case, we're going to use ASTM 6673. More just for exemplary purposes. There's no other reason why we're using that particular standard versus others, but depending on the cutting table you have, you can create presets to make this very, very, very quick. We do support exporting to the major table manufacturers in the formats that are readable and minimize any setup you have to do at the table. And there you go. In about 6 minutes, we've just created 2 individual markers. I will also point out that both of these markers are going to be associative to our pattern environment. So if we do change the grain line, for example, these markers will automatically update based on that new criteria. And there you have it. That is ExactFlat nesting and marking. And if you have any questions, you can give us a call or visit our website. This is ExactFlat for SOLIDWORKS.